Hello everyone. Recently I got some requests regarding creating a video on trigonometry. Here I am with a video on trigonometry. In this video I am going to do a brief introduction on trigonometric ratios and we will discuss some examples and I will be creating a series of video. So let's see. So there's a very interesting story that I have got for you all today. This happened when I started my teaching, like my practice teaching, which I did in our school some 7, 8 years ago. And I was teaching in grade 8 and I had a triangle model in front of me. And I showed it to my class and I asked them that what kind of triangle is this one? And the entire class unanimously said that, sir, it is a right angle triangle, and they were correct. Next thing that I did was I turned this triangle, the same triangle, and I asked them what kind of triangle is this one? And they said, sir, it is an acute angle triangle. Now, mind you, this is the biggest misconception that many students have, and this is why many of you struggle. You have to understand that whenever you are dealing with a right angle, you have to see where is the right angle. If the right angle is here, it means it is still a right angle triangle. Of course, yes, there are two acute angles, but this is still a right angle triangle. Now, the orientation doesn't matter. As long as you are able to see this is square, or if it is mentioned in the problem that it is a right angle triangle, you have to assume this is a right angle triangle. Again, I have changed the orientation. This is another right angle triangle. You can see still this triangle is right angle triangle. You know what? You can actually do this activity with your friends. You can draw one triangular model, you can cut it out, you can show it to them what kind of triangle is this one. Most of them will say it is a right angle triangle. Just turn it and see how the answer will change. This is a very interesting thing, and I have seen like 90% of the students, when you turn the triangle, they will say that this is not a right angle triangle, this is an acute angle triangle. So please be mindful that it is still a right angle triangle. Okay, so step one in any trigonometric problem is to label the sides correctly. So here I am going to label the vertices A, B, and C. This is my right angle over here. So first of all, let's discuss what we are going to do. Here, the side opposite to the right angle will be called hypotenuse. Okay, this is first thing that you have to recognize what is your hypotenuse. Second thing is that these all the other things that we are going to do, opposite side and adjacent side, they will depend upon which angle I am considering. So let's say for angle C over here, for angle C, which is the opposite side? So I will write here for angle C. So for angle C, you see, suppose if you're standing here at C and you're looking right opposite to you, you can see you will get AB as your opposite side. So your AB will be opposite side. Similarly, which one is your adjacent side for angle C? For angle C, you can see adjacent side just beside you. So the adjacent side for angle C is BC. So BC is our adjacent side. I will use another color. Let me use the blue one for not the blue. I will use the green one for angle A. Now for angle A. For angle A, if you are suppose if you are standing on this angle and if you are looking right opposite to you, you can see this side. BC is going to be your opposite side, and AB is going to be your adjacent side. Now mind you, for both of these angles, our hypotenuse is same. Hypotenuse doesn't change. So hypotenuse is AC for both of these two angles. Now what I'm going to do, I'm going to change the orientation and I will label the triangle and we will find which one is opposite side, which one is adjacent side, and which one is hypotenuse. So here I have got another triangle. So let's label, this is my right angle. Let's call it P, Q and R. First thing, we have to label our hypotenuse. You can see angle Q is our right angle triangle, and if you just draw an arrow, PR is the one that is facing right opposite to angle Q. So our hypotenuse is PR. Next, now let's, as I said, that opposite and adjacent sides will depend upon which angle you are considering. So let's say for angle P. So for angle P, if I will draw an arrow and you can see this arrow is facing QR, so it means QR is going to be our opposite side. Similarly, we know that this PR is adjacent, but PR is already hypotenuse. So the another adjacent side, we will call this one PQ as our adjacent side. So PQ is equal to our adjacent side. Next one, let's consider this angle R. So angle R, if I will draw an arrow there, see where this arrow is facing. This arrow is facing PQ. So PQ is going to be our opposite side. Similarly, we know PR is still the hypotenuse and QR will be our adjacent side in this case. So QR is equal to adjacent side. There is one more. I have changed the orientation again. So this one you can pause the video and you can try doing it by yourself. So this is our right angle. We can see our right angle is here. I'm calling it X, Y, and Z. So can you tell me which one is hypotenuse? Yes, you are right. So this side XZ is our opposite to our right angle and this would be our hypotenuse. So XZ is going to be our hypotenuse in this case. This is our hypotenuse. Next step, we will consider different vertices. So let's consider angle Z. So angle Z is here. For angle Z, if I will draw an arrow over here, we can see XY is opposite to it. So for angle Z, XY is going to be the opposite side. And the adjacent one, we know that XZ is hypotenuse. The another adjacent side is going to be this one. So O and A. Here I will have my ZY is adjacent side. I will use another color. So let's consider this angle X. If I draw an arrow, you can see this arrow is facing YZ. So for angle X, YZ is opposite side, and similarly XY, so this is opposite, this is adjacent. XY is going to be adjacent side. I hope these three examples are going to help you in labeling the opposite and adjacent. As I said, that opposite side and adjacent side will depend upon which angle you are considering. So depending upon the angle, the opposite and adjacent side will interchange. But the hypotenuse remains the same for any triangle. So as we have done in the previous cases, we have seen in the previous cases what has happened. This is how it will go. So how this is gonna help us? So far we have learnt about how to label our triangles. So once you have learned how to label the triangle, the next step is learning these three key terms. So, ka, and toa. Now remember, it is very, very important that you consider the right vertex for which you are trying to find these ratios. So stands for, you can say, so stands for sine is equal to, so sine, the angle, is going to be equal to opposite side over the hypotenuse. Similarly, this ca stand for cosine, or we call it in short cos, is cos of the angle is going to be adjacent side over the hypotenuse. And similarly, the toa stands for tangent, or in short tan, the angle. This ratio is going to be equal to opposite over adjacent. So what I'm going to do, I'm going to give you one sample problem, and here we will be considering the different trigonometric ratios. So suppose I have got a right angle trig. I have got a right angle triangle over here. So let's say this is my right angle triangle. Let's call it P, Q, and R. And we are going to consider for angle R first. So I will use this blue color, angle R. Okay, so for angle R, which one is opposite side? We will draw an arrow. We'll see which side is opposite to it. So this is our opposite side. So this means this is our adjacent, and you can see for angle Q, which is our right angle, and up the side opposite to it is PR. That means that's our hypotenuse. So once we have labeled it, we are good to go. So sine of angle R is going to be equal to opposite. So which side is opposite over here? PQ. So we will write PQ over hypotenuse, that is PR. PR. Similarly, cos of angle R is going to be what? Adjacent side over hypotenuse. Our adjacent side is QR over the hypotenuse, which is PR. Similarly, the tangent, so tan of angle R is going to be equal to tan of angle R, opposite over adjacent. So opposite side is PQ over adjacent side, which is QR. So it's easy to remember SOHCAHTOA, and the hint is simple, guys. S stands for sine, opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So for trigonometry, this should be your starting point. Labeling the triangles, labeling which side is opposite, which side is adjacent, which side is hypotenuse, and then using these ratios. So I'm going to give you one task. You can pause this video, and can you try finding what are the trigonometric ratios, sine, cosine, and tangent ratios for angle P? Okay. So for angle P, again, we will do the same thing. I'm going to draw an arrow, and I can see this is facing QR. So QR is our opposite side in this case, and hypotenuse remains the same. So PR is our hypotenuse. Remember, for any angle, hypotenuse is same. It is fixed. It doesn't changes. And adjacent side is going to be PQ. So I will write A over here. So for angle P, I'm going to find sine of angle P is going to be again opposite over hypotenuse. So in this case, our opposite side is QR. So QR over the hypotenuse, which is PR. Cosine, so cos of angle P is going to be adjacent over hypotenuse. So adjacent side is PQ over the hypotenuse is PR. And then tan of angle P, tan of angle P is going to be opposite over adjacent. So opposite side that we have got over here is QR, and our adjacent side that we have got is PQ. So this is how we can find the trigonometric ratios. In the next video, I am going to discuss how we can use these ratios to find any missing side or any missing angle. So thank you for watching. If you haven't subscribed to my channel, please subscribe it. I will be making different series of videos on different topics. And if you want me to consider any specific topic, please write in the comment and I will try to make video on that. Thank you for watching. Bye. Take care.